Good morning, and now we are going to see about sequential circuits in digital logic and microprocessor. First, we understand what is meant by sequential circuits and what is meant by combinational circuits. First of all, in combinational circuits, that is the output mainly depends upon the present state of the input value. So, what the input applying at the present state, so that is obtained as the present state of the input value. Based on this input value, the output can be performed, means that is known as the combinational circuits. And in sequential circuits, so the combinational circuits, that is examples are adder, subtractor, encoder, decoder, multiplexer, demultiplexer. So these are all the examples of the combinational circuits. And next one, that is sequential circuit. So the sequential circuits, the output is performed based on the memory. So based on the memory, that is based on 0 and binary values that can be stored in the value stored, and that recalling the memory values and producing the output. So output can be performed by using the input values, means by using the already stored values also. So that is known as the sequential circuits. So the example for the sequential circuits is flip-flops and latches. So these are all the example for the sequential circuits. These are the example for the sequential circuits. And now we are going to see about the counters. So what is meant by counters? So counters is basically used to count the number of clock pulses applied to a flip-flop. So that is known as the counters. And it can be used as, so what are the counter means, the uses of the counter. So there is the frequency divider, time measurement, frequency measurement, distance measurement, and also for generating square waveforms. So these are all the different functions and different applications of the counters. So in these flip-flops are asynchronous counter and are supplied with different clock signals. There may be delay in producing the output. Also, a few numbers of logic gates are needed to design a asynchronous counter. This is elementary and less expensive. So we are using these asynchronous counters. So next one, we are going to discuss about ripple counters. So what is meant by ripple counters means, that is ripple counter is a cascaded arrangement of the flip-flops. So in cascaded arrangement of the flip-flops, where the output of the flip-flops drives the clock input of the following flip-flop. The number of flip-flops in the cascaded arrangement depends upon the number of different logic states that it goes through before it repeats the sequence of parameter known as modulus of the counter. So based on the number of flip-flops and cascaded arrangement, so it depends upon the number of different logic states, and it repeats the sequence of parameter. So repeats the sequence of parameter means modulus of the counter. And some of the features of the ripple counters are, it is what are the features of ripple counter means, it is asynchronous counter. So what is asynchronous counter means, different flip-flops are used with different clock pulses. So that is known as the asynchronous counter, and all the flip-flops are used in toggle mode. Only one flip-flop is applied with an external clock pulse, and other flip-flops is obtained from the output of the previous flip-flop. So only one clock pulses, there is sequence of flip-flops are arranged in cascaded manner. In that flip-flop there is only one flip-flop, that is first flip-flop, there is only one flip-flop is applied with the external pulses, and based on that the output produced from that flip-flop that can be obtained from the output of the previous flip-flop, that can be applied as the input of the another flip-flops. The flip-flops applied with the external clock pulse, so that is act as the LSB, that is least significant bits in the counting sequence. So these are the features. And what are the other features means, that is there is two types of counters are there. A counter may be up counter, so that counts upward, or can be down counter. So down counter that counts downward, or that can perform both. So that is counter up as well as counter downwards, depending upon the input control. The sequence of counting usually gets repeated after a limit. When counting up for the n counter, the count sequence goes from, so for counting up, so there is two types of counter, that is up counter and down counter. The counting may be based on the counting of the sequence, it can be classified. When counting up for the n counter, the count sequence goes from 0 0 0 0 0 1 0 1 0 up to 1 1 1, and again it can be counted from 0 0 0 0 0 1, that is likewise etc. When counting downwards, the count sequence goes in the opposite manner. So opposite manner means there is 1 1 0 1 1 0, that is 1 1 1 1 1 0 and up to 0 0 0. Again it can perform the operations from 1 1 1 and 1 1 0 like to up to 0 0 0. So it can be performed in sequencing manner. So this is the difference between up counter and down counter. So that is a circuit diagram for 3-bit ripple counter using JK flip-flop. So when the input is high, that is given to the J and K, and clock signals is given to the first flip-flop. From the output of the second flip-flop, that is given to the clock signal for the output of the first flip-flop is given as the clock pulses for the second flip-flop, and the output of the second flip-flop is given as the input clock signal for the third flip-flop. So obtaining the results as Q0, Q1 and Q2. So based on this, the JK flip-flop can be performed the operations. In the circuit shown in the above figure, that is Q0 will toggle for every clock pulses, because JK flip-flop work in toggle mode when both JK are applied 1 1 or high input. The following counter will toggle when the previous one changes from 1 to 0. And this is the truth table for the ripple counter. So that is counter state, that is 1 to 7, and Q2, Q1, Q0 that can perform the operations as the binary values, that is 0 0 1 0 0 1 and up to 1 1 1. So based on the counter state, it can performing the operations, it can giving the outputs. And the 3-bit ripple counter used in the circuit above has 8 different states, each one of which represents a count value. Similarly, a counter having flip-flops can have a maximum of 2 to the power n states. The number of states that a counter owns is known as its mod counter, that is modulo counter. Hence, a 3-bit counter is a mod 8 counter. It is represented as a mod 8 counter. A mod n counter may also be described as a divide by n counter. This is because the most significant flip-flop, that is the further flip-flop from the original clock pulse, produces one pulse for every n pulses at the clock input of at least significant flip-flop. So that one triggers by clock pulse. Thus the above counter is an example for the divide by 4 counter. So next one, the advantages of the ripple counter in digital logic. So it can be easily designed by T flip-flop or D flip-flop. So ripple counter can be easily designed by T flip-flop or using the D flip-flop, and it also can be used in low speed circuits and divide by n counters, and it is used as truncated counters to design any mode number of counters, that is mod 4, mod 3. So any number of counters can be designed by using the ripple counters. Thank you.